Hello everyone, welcome to Rick's Revelation team presentation. The scenario for our workshop is autonomous vehicle. So what is an autonomous vehicle? It is an autonomous car capable of sensing its environment and operating without human involvement. Then, this behavior is possible because an autonomous vehicle has an internal information system with different layers and components that communicate with each other to control the car. These layers are perception, network, and application. Basically, the autonomous vehicle combines a variety of sensors to perceive their surroundings, such as radar, LiDAR, ultrasonic sensors, video cameras, and GPS units, which data is transferred to an application layer through the local network area. Then, computer unit from application layer interprets sensor information to identify appropriate navigation paths, as well as obstacles and relevant signage. So, analyzing the present architecture, we assume that all layers are interconnected and that there are many dependencies between them. So, to keep a narrow scope, the group has decided to explore the risks inherent to the application layer, with focus on the interaction between computing unit and internal storage. Other risks involving assets and layers connected to the application layer, computing unit, and internal storage were also identified and properly assessed, such as network and perception data. Relevant business assets and their security criteria. In our assessment, we identified 10 risks. 4 of them are high priority and will be the ones that we will discuss in the presentation. Then, these 4 high priority risks affect 6 business assets in total. This table gives a quick overview of how our high priority risks exactly affect business assets by defining their security criteria in terms of availability, integrity, and confidentiality. Okay, let's talk about relevant system assets and how they support business assets. So, business assets affected by our high priority risks are supported by 7 different system assets. This matrix gives a high level overview of which system assets support which business assets. Most of these business assets are one way or another related to one of the following 3 system assets: computation and intelligence in computing unit, data for these computations that is stored in internal storage, and moving this data to vehicles' internal network. Trade-off analysis and risk prioritization. To determine the priority of the risk, we conducted a security risk assessment in which we analyzed the value of the affected business asset, the risk level before and after treatment, and the cost of the countermeasures. After that, we analyzed the risk reduction level versus value, the risk reduction level versus cost, and the cost versus value. Based on the risk prioritization analysis, we concluded that the risks 1, 4, 6, and 9 had the highest priority level. So according to the graphs, these risks should be addressed first, and this is why they are included in the presentation. This is an overview of 3 risks analyzed. The slide characterizes what decisions, requirements, and controls should be defined and implemented in order to mitigate these possible risks. So let's start. For the risk 1, unauthorized access to computer unit and modification of the firmware leads to loss of integrity of command calculation process and loss of the command's availability. So the treatment decision is risk avoidance and security requirement. Only authorized servers shall access to the system and the control deploy intrusion detection system. For risk 6, exploit vulnerability of the system to change the traffic configuration data causes loss of integrity for traffic configuration data. So we have risk avoidance and a security requirement ensure the system of cryptography protecting internal storage, and as a control, encrypt traffic configuration data. Finally, for risk 9, that is missing access controls in computer unit debugging port leads to loss of confidentiality of traffic configuration data. The risk avoidance is the treatment decision, and as a security requirement, the access to computer unit serial debugging port must be allowed only for authorized devices. As a control, implement authentication for computer unit serial debugging port. Risk 1 was analyzed using the risk-aware secure tropos. As can be seen in the graph, the 2 main actors, the computer unit and the attacker, the business assets and the system assets involved are represented along with the main tasks and objectives of each part. The attacker exploits the vulnerability due to the deficient access control of the computer unit from remote back-end servers. The attacker updates the system with a rogue firmware to affect the integrity of the command calculation process. For the risk 6, the security risk-oriented misuse case model has been used to represent interaction from actor and violator between system and business assets. Although simple and with limitations, this model brought a more understandable visualization where both agents and assets interacting within the system could be clearly distinguished. Risk 9. Using activities for security risk management. This diagram describes one potential way of violator gaining access to traffic configuration data. There are two different paths of activity described in the diagram. One path describes activities of violator using missing authentication vulnerability, and this leads to loss of confidentiality in a business asset. Okay, now let's have further details for security risks 4. Remember that security risk is a combination of a threat with one or more vulnerabilities leading to a negative impact harming at least two or more of the assets. So let's understand this risk in its main constituents. So we have system assets that are the network and internal storage, which also have vulnerabilities that are lack of encryption or perception data in the network and updated application components installed in the operating system of the internal storage device. And our threat agent is a TF that is able to intercept the transmission channel to modify the perception data and inject ransomware to encrypt the map data. The attack method used by the threat agent is man-in-the-middle attack to intercept the transmission channel and modify the perception data, and ransomware WannaCry attack to encrypt map data. As a negative impact over our business asset, we have loss of integrity of perception data, loss of availability of map data, and routed calculation process. So having these concepts clear, we have modeled this risk in BPM for the following scenarios: context and access model, the security risks, and security countermeasures. Okay, let's see the context and asset model using BPM. So in the diagram, we can see that the precision data is collected by the sensors, radar, and camera devices. So this data is transmitted via the local area network to the computer unit, which is the one who receives this information and also processes, and this data processed is the input for the routing calculation process in the computer unit. So basically in this process, the computer unit computes all the sensory input, that is the perception data, with the internal data stored in the internal storage, such as map data, traffic sun data, to identify an appropriate navigation path to take. So once the path is decided, the computer unit sends instruction to the car's actuators for controlling the vehicle. So basically these are commands that are translated by actuation module as acceleration, braking, and steering. So now let's talk about security risk model oriented BPM. So here in the diagram we have highlighted in yellow the system assets and business assets that have been affected by our risk scenario. So let's start. So here we have a TF that is our threat agent that is able to intercept the transmission channel to modify the perception data due to the lack of encryption data in the network. So the transfer is intercepted and the TF modifies the perception data and injects a ransomware attack to encrypt the map data. The next step is that the computing unit receives and processes this data, including the ransomware, and this activates the ransomware attack, where the access could be exploited in the internal storage because of updated application components installed in the operating system of the internal storage device. This leads to the encryption of the map data. So at the end, we have a negative impact of the integrity of the perception data that has been compromised, and also we have a loss of availability of map data and routing calculation process, as there is no map data available for the process. Okay, so security countermeasures. So our risk treatment decision is risk reduction. Security requirements, we have the network shall prevent unauthorized corruption of perception data transmission. Application components of internal storage must be updated once per week, and internal storage shall not have a single point of failure. As a controls, we have implement encryption functionality in the network to encrypt perception data transmitted, implement a vulnerability and patch management process, perform every week vulnerability scans on internal storage and also patch them weekly, and perform a daily backup of the data in the internal storage. So in the diagram we can see in blue all the countermeasures that we have defined. So first of all, we have the encryption, the perception data with a checksum verification. So in case this verification operation doesn't match with the original message, we don't process this information. And also for internal storage, we have established as a countermeasure the backup. So in case there is an issue with our internal storage, we can recover the backup and restore our operations. And finally, we have enabled a secure connection to internet for updating all the application components of the internal storage.